Okay, so this is the problems. Okay, so the frame plan layout. So given here, for the location for this frame is near suburban zone 1. So directly mentioned here is zone 1 of Malaysia wind speed mapping. Okay, and the topography, the flat area slope is less than 0.05, and the building around within 1 kilometer radius. Okay, so bangunan-bangunan, okay, the around building is within the 1 kilometer radius lah. Okay, so other information is similar with the example 2.1, and this is the 7 stories building 1 to 7. Okay, and this is the height for each column. So the ground column is 4 meter, 3.5, 3.5, 3.5 from the second. This is the second level here up to the 7 level. Each column height is 3.5, and the total height, the total H is 25 meter. Okay, 25 meter. Floor 4 plus 3.5 multiplied with 6, okay, equal to 25. Okay, 25 meter. Okay, and this is the simplified diagram. So this is the H here, H 25, B here is 18. Okay, location of the frame building is in Kuala Lumpur, zone 1. Okay, refer to figure 3.1, Malaysia Standard. Kuala Lumpur is in zone 1. The terrain is the suburban terrain for all direction. Topography is the ground slope less than 1 in 24 greater than 5 kilometer. Construction is the reinforced concrete. The sway frequency, the NA equal to NC, which is 0.2 Hertz. The mode shape, the linear K is equal to 1, and the average building density is 160 kilogram per cubic meter. Okay, so this is the side elevation. Okay, this is the side elevation here. This is the side elevation. Okay, 6 meter, 6 meter, 6 meter. 6, 6, 6 equal to 18 here, 18. And the height here is 25. Okay, 6 multiplied with 3.5, 21 plus 4 meter here is 25. So this is the total H. Meanwhile, for the overall length here, the length here is D equal to 51 meter. Okay, 51 meter. So from here to here is 51, 35 plus 8 plus 8 plus 16. Okay, 51 meter, and the wind comes from this direction. Okay, this direction. So wind comes from this direction. Okay, so meaning when the wind comes from this direction, so this is the windward side and this is the leeward side. So it is expected the shape of the pressure here is uniform. Ini uniform segi empat, sorry. Saya tak boleh, I cannot using this pencil here, I cannot write it. This is the straight line uniformly. Okay, loading pressure here, this is the leeward side, and this is the windward side. So the windward side, this is the ununiform. Okay, ununiform, load start from 0 at the ground, and for each story here, it's increasing. Okay, increasing. So you need to calculate for each story. So yang ini everything is constant. Okay, once you calculate one value, so it is constant for all level. Okay, because this is uniform distributed. So then in this example, you need to calculate this pressure and also this pressure, both pressure, and later this pressure, the wind pressure in the windward side and the wind pressure at the leeward side later will be totally together. Okay, and the equation is for this example is using the analytical method, analytical procedure. So the equation for the pressure is, this is the wind pressure equal to 0.163 multiply with the vidas. Okay, the vidas here is the what we call it as the design speed. Okay, all right, for the wind speed, design wind speed. Okay, power of 2 multiply with this factor, multiply with the dynamic factor. Okay, multiply with the aerodynamic shape factor here, and multiply with the dynamic responses here. Okay, yang inilah. Okay, so unit is in PA Pascal. Okay, so this is your objective to calculate this one. Okay, at the leeward side and also at the windward side. So leeward side here you will calculate only once, sekali sahaja, because from the bottom to the top, total height 25. So the shape of the loading, the pressure is uniform. Okay, uniform. Okay, compared to this pressure on the windward side, okay, so the pressure is increasing from the bottom to the top. Okay, so you need to calculate 1, 2, 3, 4, 5, 6, 7 times. Okay, this is what we call the wind speed. One wind speed, second wind speed, third, fourth, fifth, 6, and 7 using this equation. And meanwhile, for the leeward, only once. Okay. Okay, so using the analytical procedure in section 2. So this section 2 from the equation 2, page 24. Okay, if not mistaken, page 24. Let's look at page 24. So this equation is at page 24. Okay, Malaysia Standard calculation of the wind action. So, and this is the side wind. This is side wind. Okay, so this is page 25. Sorry, clause 2.4. Okay, clause 2.4, page 25. So this is equation number 2 to calculate the wind pressure using the analytical method. Okay. Okay, and this density of air, which can be taken as 1.225, and also thus multiply with the 0.5 is equal to 0.613. So directly use 0.613. Okay, for this one. Okay, so this one is equal to this value. Okay, so equation 2 is for the wind pressure using the analytical method. Okay, and before we proceed with the slide, I want to write the summarize here. So I want to summarize this one. So this is the equation. Aku cantik tulis saya. Multiply with the dynamic response. Okay, so dynamic response. Okay, so first you need to determine this design velocity. So this value, is the V design, the wind speed design. Sekejap kenapa saya tulis design panjang sangat? Okay, so it's equal to V seat multiply with L, and this V seat is the side wind speed. Okay, so this is the side wind speed, and this side wind speed, the equation is V seat equal to Vs multiply with the mg, this is the wind directional multiplier, multiply with the mz cat. Mz category here is the terrain height multiplier, multiply with the ms. Ms is the shielding multiplier, multiply with the mh. MH here is the hill shape multiplier. Okay, so this Vs, the basic wind speed, okay, this basic wind speed is referred to figure 3.1, okay, either zone 1 or zone 2. Okay, in this example, Kuala Lumpur is in zone 1, thus the Vs, the basic wind speed here, is equal to 33.5. Okay, 33.5. And next here is the MD, the wind directional multiplier. Basically, we take it as 1. And this, the MZ cat, later refer to table 4.1. Okay, table 4.1. The MS here is from table 4.3. And MH here is refer to clause 4.3. And basically we take it for the MS, MH is equal to 1. And this L is the importance factor. Okay, so this important factor is referred to table 3.2. Okay, 3.2, there are 4 category, 4 category, category 1, 2, 3, and 4. Okay, so done. So next is this one. So this is the aerodynamic shape factor. Okay, so this aerodynamic shape factor, saya pergi bawah sini ya. This aerodynamic shape factor, the equation is equal to CPE. This CPE is known as external pressure coefficient, multiply with the KA, multiply with KC, multiply with K1, multiply with KP. Okay, so this CPE is referred to table 5.2a for wind watt. Okay, and table 5.2b, okay, this is for the lee watt. Okay, and this KA, KC, K1, KP basically is equal to 1. Okay, unless stated otherwise. Okay, this one you can refer to appendix C. Okay, next, you determine this one. Okay, so this is the dynamic response. Okay, this dynamic response is equal to 1. Okay, unless the structure is wind sensitive. Okay, unless this structure is wind sensitive, and then refer to section 6. Okay, section 6. We have seen this section 6. Okay, so under this section 6, okay, C dynamic is equal to 1 unless the structure is wind sensitive, refer to section 6. Okay, so this is section 6. Langkah pergi bawah. So C dan CD. Sekejap Okay, so go down here. Okay, continue here. Okay, so we continue here. So this is the dynamic response. Okay, from section 6. C, D, Y, N equal to 1 plus 2 LH. Okay, square root. Tak payah salin sayang, semua ada kat dalam Malaysia Standard. You all salin. Tambah GR power of 2 SET. Okay, divided by rational of structural damping. Ini bahasa dynamic punya analisis lah. Okay, so divided by 1 plus 2 GV. So this GV is the peak factor, equal to 3.7 lah, kalau if not mistaken lah, kita tengok balik. So multiply with the LH. So this LH is equal with this LH. So this LH is the turbulence intensity at Z equal to H. Okay, alright. So this one, the LH here, okay, is referred to table 6.1. Okay, 6.1. Okay, so as here, this as here, mana yang saya boleh ni lah, as here is refer to page 56. Okay, the as, the ET here also page 56. Okay, and also the BS here. So the BS here also page 56. Okay. Other than that, kita lihat dekat page 56. Everything is at page 56. Ada banyak equation lain lagi. Okay, so ini pun ada equation dia. Okay, yang ini dia akan kembang lagi ya. Okay. Okay, so we return to this slide. So design with pressure using this equation. So first, determine the design wind speed. So determine the design wind speed. So kita determine this one first. So this is the first value to be determined. Okay, so the design wind speed is equal to the V seat. Okay, where the V seat is the side wind speed. The side wind speed is equal, multiply with the L. The L here is the importance factor. Okay, importance factor. So the V seat here, first calculate the V seat here. So the V seat here is equal to Vs, the basic wind speed, multiply with the wind directional multiplier, multiply with the terrain height multiplier, multiply with the Ms, the shielding multiplier, multiply with the hill shape multiplier. Okay, so the Vs, the basic wind speed, based on the figure 3.1 here. Okay, so this is figure 3.1. For the basic wind speed, zone 1. Kuala Lumpur is at zone 1, around here. Okay, the Vs is 33.5 meter per second. Okay, 33.5 meter per second. And next is the wind directional multiplier is equal to 1. The MZ category, the terrain height multiplier, refer to table 4.1. Okay, so this is table 4.1, the terrain height multiplier. So this is the height. Okay, height. So you need to calculate at the windward side and also the leeward side. Okay, so the Z. Okay, ini penting ya. So this is important. The symbol between H and also Z. So that is if you see the Z equal to H. Okay, so this is a very important. So for example here, this is the frame. Okay, build the frame, the outline. So this is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. Okay, tengok betul-betul This is very important. You need to use this understanding. You need to consider this one in your project. So here is for 3.5, 3.5, the length kan, 3.5, 3.5, 3.5, 3.5, and the total height here is 25. Okay, so this is the difference between in the calculation for the leeward and the windward. Okay, so this face is the leeward, and this face is for the windward. Okay, for the leeward, for the leeward, in the question, in the example, it shows for the leeward, it takes total H equal to 25. Okay, so the 25 here is range between 20 and 30. 25 is somewhere around this range, 25. Okay, 25. And we select, in this example, select category 3. So for category 3, category 3 is the terrain with numerous closely spaced obstruction 3 to 5 meter height. Okay, such as areas of suburban housing. Okay, if look at the question, if look at the early question, it stated that so the topography here is the flat area, slope less than 0.05, building around within 1 kilometer radius, and also the ground slope less than 1 in 24 greater than 5 kilometer in all direction. Okay. Yang ini adalah space obstruction 3 meter to 5 meter height. Okay, the suburban. Mention suburban kan earlier tadi. Okay, again we come here. So, and we need to find value here. So, using the interpolation, then you get the value here. So, this is for the total height using the 25. Okay, 25, once you get this value, the MZ, the terrain height multiplier here, so you can use this value for the leeward, because leeward here, the loading is uniform. Okay, uniform from bottom to top of the flat. Okay, rumah pangsa ni kan dia punya negative pressure here at the leeward side here. Okay, is uniform, so you can use only one value of the terrain height multiplier. Okay, so listen here, this is important. Okay, for the meanwhile, for the windward side, this windward side, you need to calculate 7 times, because it has different varieties of the height varieties. Okay, first you need to determine the MZ cat using height 4 meter. So 4 is between 3 and this, so the value is 0.75. Okay, and then 4.7, so start 0, 4 plus 3.5 is 7.5, so 7.5 is between the 5 and 10, between this range, so you need to do interpolation, and then 4 plus 3.5, 3.5 for the level number 3. Okay, so that it increasing. Okay, so for this windward side, there are 7 multiplier value. For the leeward side, only 1 multiplier value, where we take the height is equal to 25, the total H. Okay, so in this case, the terrain height multiplier, so equal to 0.97. So this 0.97 is based on the total height 25. Okay, so this 20 height 25, this data 0.97 is for the leeward side, and also for the windward side is for the top level. Okay, the level number 7. Okay, sebab total level number 7 tu totally adalah 25 meter. So itu sama saja ya. Okay, so the MS here, the shielding multiplier, refer to table 4.3 is equal to 1. MH is equal hill shape multiplier clause 4.3. Okay, so and the importance factor table 3.2. Okay, so kita akan lihat MS, MH dan juga L. Oh, dah nak habis So this is table 4.1. Okay, so this is for the terrain height multiplier, saya dah cerita tadi. Okay, and this is the important factor. So the important factor here is we'll select category number 3, where the building and structure where the primary occupancy is one with which more than 300 congregate in one area. Of course lah, 7-story building, more than 200 people lah. So we take this value, the important factors, as 1.15. Okay, and this is table. Later you can refer to table 4.3 for the shielding and also hill shape multiplier. Okay, boleh ya, sebab dia memang kita selalunya ambil 1 lah. Okay, alright. And next is to calculate this aerodynamic shape factor. Okay, we have done with this value, and then we proceed with this. aerodynamic shape factor. Okay, so this equation is equal to the CPE, external pressure coefficient, multiply with the error reduction factor, combination factor, local pressure factor, and also porous cladding reduction factor. And all this factor is equal to 1 unless stated. Otherwise, kalau lain daripada ini, you need to refer to appendix C. Okay, so for the external pressure here, refer to the table 5.2a for the windward wall and table 4.2b for the leeward wall, and for D divided by B is equal to 51 meter divided by 18 meter. Okay, okay, so this is D, and this is B. Okay, so this is table 5.2. This is for the windward wall. Okay, so for the H less than 25. Okay, and also this is H more than 25 meter. Okay, so we take here, yang kat sini lah, kita punya H kita adalah yang ini sepatutnya. Oh sorry, for the windward. Okay, so 0.8 lah, sama lah ini for buildings on ground. In our case here, this is the building on ground. Okay, so this is building on ground. Ada lagi satu adalah elevated building. Okay, elevated building, kalau you terus nampak ada pier, ada macam kat bawah tu, dekat basement tu ada macam kolam tinggi, lepas tu baru ada first floor. Okay, okay, our total height here is equal to 25 meter. So kita ambil yang ini sebenarnya, sorry betulkan balik. So this is for building on ground 0.8 when wind speed varies with height. Okay, so sebab kita punya is equal. Kalau more than 25 terus ambil 0.8. Okay, or 0.7 when speed is taken for Z equal to H. Okay, so this Z kita baca dekat apa ni, the terrain height multiplier. Okay, this is Z. Yang saya conteng tadi sekejap saya nak tunjuk. So this is the Z. Okay, contohnya yang tadi guys, for example, this is the dia bukan sway lah, saya this not reflection saya ni. So this is the pressure kan. Pressure is increasing. Okay. Dia adalah windward side. Windward side. So kat sini kita H dia, H kat sini, so H, the definition for H and Z is same. Okay, but we use this side, at the leeward side we take it as H. Okay, at the windward side we call it as Z. Z kita simbolkan sebagai Z. Sebab Z ini berbeza, dia ada, it starts from 4 meter, then increase to 7.5, increase lagi with the additional 3.5, increase lagi with the additional 3.5 up to 25 meter. So for the height at the windward side, we symbol it as Z, because it varies from 0, 4, 7.5, increase up to 25 meter. And meanwhile for the leeward side here, we use symbol H. Okay, boleh ya? And using this table, 5.2 for the leeward wall, so this is the alpha. Okay, so this is B of D divided by B. Okay, this is alpha, is not given in the, our alpha here is not given in the question. So alpha is the roof. Apa ni, sudut lah. Okay, kat sini ya. Okay, then we get it around berapa ya, D divided by B, dalam 3 point something ke 2 point something saya lupa. So you need to do the interpolation and the answer is equal to 0.25 ya. The watt is in negative value sebab dia adalah negative pressure. Okay, please make sure that the aerodynamic shape factor ni, the CPE ni, external pressure ni, for the leeward wall is the negative 0.25. Okay, then no, it should be in the negative sign. Okay, boleh ya, saya ambil masa sikit hari ni. Okay, and next we calculate the design wind pressure for the sea dynamic. So this is the dynamic response factor using this equation. Okay, this equation. So next is the this stage. Okay, using this equation. So this equation is given in the Malaysia standard. Okay, Malaysia standard in page 56. Everything is written in written in page 56. Jangan risau pasal ni. Okay, so this is the equation and all this is the definition for each symbol. Okay, And for each symbol here, so given here the formula related to each symbol. Okay, so this is the ET, the spectrum turbulence, this is the size reduction, and this is the background factor. So under the background factor, here is the measure of the effective turbulence length, which is equal to 1000 multiplied with the H divided by 10, kuasa 0.25 lah. Okay, alright. So then the turbulence intensity, for table 6.1, so refer to table 6.1. So the table 6.1 in the page 57. Okay, page 57. So this is table 6.1. Okay, so again, so this is the height. For the leeward side, here, the height here is equal to H. The Z here, Z is equal to H for the leeward here. Okay, where the value for H here is 25 meters. So you take 25 meter and terrain category number 3, and you do interpolation and you get the answer here between 0.21 and 0.20. Okay, so this is the leeward side. Meanwhile, for the windward side, you need to calculate it 7 times. Okay, 7 times. No, calculate. You need to determine it 7 times for each level, for each story. 4 meter, 7.5 dan sebagainya sampai up to 25. Faham ya? So windward. Okay. So for the GV here, peak factor given as equal to 3.7. Mentioned earlier. Okay, saya dah tunjukkan GV ni dia dekat peak factor, dekat you refer lah in page 56 to start from 56 you can find the GV here. Okay, saya nak tunjuk jugalah. So this is the GV. Okay, equal to 3.7. Everything is here. And the BS, the Bragg factor, is using this equation. This equation, the H is equal to 25, and this is the H, S. As the first, again, draw kat sini, Okay. So for the leeward side, okay, total H is 25. Okay, and the S here is equal to 0 here, 0. Okay, so you gunakan S is equal to 0. Boleh ya? So nanti dia increase lah for this side, dia ada 4, 7.5, nanti you kira lah. Okay, so BSH. This BSH is the, what we call it as the, the BSH is the average breadth of the structure between the height S and H. Okay, so dalam definisi yang mudah, so this is the wind direction. So this is the wind direction. So this is the BSH. Okay, depends on the wind direction. Kalau wind direction dia kat sini, BSH dia yang ni lah. So this is the wind direction. So this is the BSH. So take it as 51. Okay, 51. And the LH here is equal to 1000 H divided by 10 power of 0.25. Okay, so stated here. So this is the LH. Okay, dia ada dekat dalam description for the BS. Okay, this one done. This one is done. LH here is done. And next is the S, E, and also ET, and also GV. GV is done. Okay, S and also ET. So the S here is the size reduction using this equation. So no need to worry, this equation is given in the Malaysia Standard. Start from the page 56. So the NA here is given in the question. NA 0.2 Hertz given. And the B0H equal to BSH equal to 51. Okay, boleh ya? Sebab dia tak ada bukit ke curun ke apa kan. So this is the spectrum turbulence. So using this equation. So this equation is given in the Malaysia Standard also. And the N here is calculated using this equation. Adalah, so first you need to determine the N. Later you substitute this N into the equation. Then you get the spectrum of turbulence. And this ratio of structural damping to critical damping refer to table 6.2 is equal to 0.05. Okay. So this is table 6.2. Okay, 6.2, our case is reinforced concrete. Okay, unlimited limit state, reinforced concrete structure, 0.05. Okay, 0.05, and the GR, the peak factor for resonance response here is using this equation equal to 3.09. Okay, so this equation NE is given earlier. Saya rasa ada earlier tu. Dia kata NE or NE, yeah. And this is the table 6.1, and this is the table 6.2. And this is the summary. Okay, so look here. So to make it easier, you need to summarize it in the Excel. So this is the wind watt for the wind pressure at the wind watt side, and this is at the lee watt side. Okay, so this is level 1 to level 7, and this is the height. Okay, so this is the Z. Okay, Z, when we symbol the height as Z, so this is used for the wind watt. Okay, for the wind watt. Okay, so nanti later you dapatkan nilai-nilai yang berkaitan dengan Z lah, MZ cat dan sebagainya. Okay, so this is the MZ cat. Okay, this MZ cat, this value, okay, nampakkah dia berbeza kan? So this value is based on the 4 meter, 7 meter, 11, 14.5 up to 25. Faham ya? Saya sebut tadi sebab MZ for the wind watt dia berbeza. Okay, sebab for each level, because the shape of the pressure is ununiform. Okay, non-uniform shape. Okay, boleh ya? Okay, so yang ini done. So this is the wind watt. Okay, then the objective of this table is to calculate this one and this one and this one. Okay, so this one has been calculated in the example 37.4. Okay, the design, the wind load design. Okay, the wind design. Okay, has been calculated 37.4. So later you need to calculate for level 6, 5, 4, 3, 2, and 1 based for the MZ cat. However, for the lee watt total is 25 meter. You ambil je nilai ni 25 kan? So 25, so samalah nilai dia. Faham ya? Okay, so once you get this one dah dapat, then you substitute each of these V thus design it into this equation. Okay, so this one comes from this equation, and also same with this one. L here is represent the lee watt, the W here represent the wind watt. Okay, so you substitute everything. So for the wind watt, again, for each level the pressure is different. Okay, this starts from the low pressure. When the height is increasing, so the pressure also increasing. Okay, because the height is increasing. And then for the lee watt, we only take the one constant data. Okay, and this lee watt this is the in negative value, because it want to show that this is the apa ni, wind kan, so wind pressure, so dia suction area kat sini, suction area kan. Okay, suction area meaning dia punya loading tu, the direction is, dia akan, kalau kat sini the wall here is the weak wall, lemah, dia akan terpisah lah. Okay, the suction area. So because this is why this is negative, and from the top to the bottom, the pressure, wind load pressure is same value. Okay, because the H we take it as equal to 25. Okay, boleh ya? So look here, for the V, that's for the wind watt, the symbol is Z, because the H is symbol as Z, because the Z is different from each. The height is different for each level, and for the lee watt, we symbol the height as H. Okay, because we take it from bottom to top as a 25 meter. And this is the total load. The total load is total of 910 plus. So even though here is negative, this negative just to show you that here is the negative pressure which induce the suction pressure. Okay, the suction pressure. So however, for the total one set of this kita panggil response. So kita total it up, 910 plus 285. This one total it. When you total it, you ignore the negative, because negatives just want to show that this is the suction area, the suction pressure. Okay, so if you want to check either it is correct or not, so the pressure is increasing. Okay, from the top to from the bottom to the top, and this is the summarized for your analysis. So this is for the pressure at the windward wall, and this is pressure at the leeward wall. Okay. Alright, nampak increasing kan? So this is the total. Dan kita sampai sini saja. Nanti kemudian kita akan masuk design stage. Okay, so thank you for this class and this example.